Initially, I reasoned that ammonium chloride, when it dissolves in water, will create two ions, ammonium ions and chlorine ions. Since chlorine is the conjugate of HCl, a strong acid, chlorine will not react at all in water, so I'm completely ignoring it. The ammonium ion, however, will react in water, and it produces ammonia, which is a weak base, and also hydronium. I then took 55, which is the mass of ammonium chloride that was dissolved in the water, and I divided by 53, which is the mass of ammonium chloride, and I figured out that's the number of moles of ammonium chloride. That's also the number of moles of ammonium. I divided by 2 since it's 2 liters of water, and so the concentration of ammonia is 0.52. Setting up my SRE chart, the starting concentration of ammonium should be 0.52, the amount that reacts should be X, and the equilibrium amount should be 0.52 minus X. Since there is no ammonia initially and no hydronium initially, I used X and X to represent the amounts that form, and also that would be the amounts at equilibrium. Then I have to solve for the value for X. Of course, the equilibrium expression comes out to be exactly what we would think. It's X squared over 0.52 minus X equals K. The real question is this a Ka, a Kb, or something else? And in this case, it represents a Ka value since ammonium ions are reacting in water to make hydronium. Furthermore, I know that Ka times Kb should equal about 1 times 10 to the minus 14. And I think I gave you that the Kb value for ammonia is 1.8 times 10 to the minus 5. Substituting in, I divided it and found out that Ka for the ammonium ion is about 5.5 times 10 to the minus 10. Graphing this in my calculator, I found out that X equals 2 times 10 to the minus 5. And if you look back to the SRE chart, I believe S represents the concentration of hydronium. So therefore, the log of 2 times 10 to the minus 5 should tell us the pH. And the pH is about 4.7.